This is the Heart Nebula, 130 frames, 6.5 hours of integration, and processed with a modern AI workflow. A few years ago, I made a video about integration time, how much you actually need to get a result worth sharing. I gave you a number. I was right at the time. AI processing tools have changed everything since then. So I wanted to do a test now and see whether that answer still holds, and to investigate what effects AI tools actually have. I'm going to discuss with you 3 comparisons of the same target using the same telescope. The results generally surprised me, and one of them changed the advice I'd now give. Comparison 1, the old workflow versus the new workflow. First, here's version A, with a traditional workflow and no AI tools. This is how I would have processed this image 3 or 4 years ago. The nebula structure is visible. The stars are present, but the background has a color cast. The noise floor is limiting how far I can actually push the detail, and the stars are competing with the nebulosity. Now version D, same data, same telescope, full modern AI workflow, GraXpert for background extraction, and I've also used NoiseXTerminator and StarXterminator in Photoshop. The nebula structure is much richer, the background is cleaner, the detail in the outer regions is clearly more apparent and more obvious. The AI workflow on deep data produces a noticeably better result. And that's not really a surprise, is it? That's what I expected. I'm sure you did too. The interesting question, though, is what happens when the data isn't this deep? Do the AI tools still perform well? And could they make up for less integration? A quick note then on the test I've carried out. I used 130 frames of data taken on the Heart Nebula, 6.5 hours at 3 minutes per frame. I then took 23 of those frames, roughly 60 minutes, to represent thin data. That is data that's not really going to be enough for a satisfactory image. I processed 4 versions of this data. Version A, using a traditional workflow without any AI tools. Version B, thin data, using the same traditional workflow. And version C, again, not enough data, using full modern AI. Version D is full data and full modern AI. Comparison 2, what does AI do with thin data? The second comparison I'd like to make in this video is that between 23 frames, which is roughly 60 minutes or 1 hour of integration time, and this is not a lot, but it's what most of us collect on an interrupted session. Version B first, the thin data using a traditional workflow. This is what thin data looks like the old way. Noisy background, color cast, limited nebula detail. This is why the advice was always to collect more data. Now, let's look at 23 frames through the full AI modern workflow, and this is version C. What can we see now? Well, we can definitely see more nebula structure, and the background is cleaner. The AI tools are extracting detail that the traditional workflow couldn't reveal in the same data. But if we do look closely, and this is really important, the result still looks very processed. The background is not very good. The contrast is harsh. There's visible noise that the AI has struggled to fully suppress. So the AI has not performed miracles because the exposure is still lacking. Therefore, I think we can say from this test that 60 minutes just isn't enough exposure time. Despite the AI tools that we have these days and all the work that they do for us, they're still fighting against a signal floor that's simply too low. There isn't enough photons there for the tools to work cleanly. So now comparison 3, the crossover point. To find the crossover, I processed a third version, 65 frames, just over 3 hours of data. the same full AI workflow as version C and D. Let me first of all mention what do I actually mean by the crossover point? Well, we've seen that with very little data, about an hour, it's not enough that AI tools have sufficient data to make a huge difference in the final image. But at what point? This is what I'm calling the crossover point. How much integration time do we really need in order to give the AI tools the data that they can use to really make a significant difference to our images? So here's version E. This, as you can see, I hope, is a genuinely good image. Okay, it's not perfect, but it's a good image. The nebula structure is clear across the whole frame. The background is controlled and natural looking. The detail in the outer regions is visible. This looks like a real astrophoto, not an over-processed result. Now compare it to version A, which was the traditional deep stack. So 3 hours with AI versus 6.5 hours without. Version E is competitive. In some areas it's better. The outer nebula detail, the background cleanliness. In others, version A holds its own. The stars are more natural looking. The image has less of a processed feel. They're not the same result, but they're comparable results from very different amounts of data. So what's the verdict and what does this mean in practice? What's the actual number, the crossover point, where AI tools actually do make a significant difference to the final image? Well, before I give you that verdict, let me just tell you that I've put together 2 free guides that complement what we're talking about here. One is an imaging checklist, everything that I go through before a session so I don't waste a clear night. The other is a guide to 50 must-image nebulae, lesser known perhaps, with notes on what makes each one worth attempting. Both of these are free and you'll find a link in the description, but just to mention it here also, it's astroimagery.com/get cheat sheet. Go sign up. So has AI made long exposure astrophotography obsolete? Based on this test, no, but it has changed the game significantly. Here's what the data actually tells me. Below about 2 hours, AI tools can struggle. The signal floor is too low. There simply isn't enough data and there aren't enough photons for the tools to work cleanly. You'll get more detail, that's true, than if you use the traditional workflow, but the result will look processed rather than natural. Above 3 hours, however, the modern AI workflow starts producing results that are generally competitive with deep traditional integration. Not identical, but comparable in quality and in some ways better. The practical implication is this: if you're currently cutting sessions short because you think thin data is useless, you're probably right below 2 hours. But above 3 hours, the modern workflow can do significantly more with your data than you might think. Integration time does still matter, but the minimal viable session length has certainly dropped. That's a meaningful change for us. I'd generally like to know, has your minimum session length changed since you started using AI processing tools, or are you still trying to get the maximum that you can from your integration time? Drop it in the comments. I read every one. It won't take a moment, and let's get a conversation started here. If this was useful, there's more on the channel. I'll put some relevant videos in the description, and I'll see you in the next one.